Okay, just wanted to show a couple of things with this VFR Nav Log and some other features or some other applications like SkyVector that you can use. So this follows the general format of a nav log where you have multiple fixes that you're going. I've got 2 Whiskey 6, Leonardtown, top of climb, and that's going to be dependent on your aircraft and how high you're going, where a top of climb is. But I'd like to pick a quick on-course heading initially, both a ground reference point and an on-course heading. So just some of the numbers, got an altitude column here. This is showing that we're climbing pretty much at 4,500, and that would be in the center of the Potomac River. So looking at SkyVector, somewhere over here would be my top of climb. I've got Leonardtown as an on-course checkpoint, and then top of climb living somewhere over here. In terms of the winds, you can pull these from a couple different places. Aviationweather.gov is a good one, but with aviationweather.gov, I got that note off to the side here. With aviationweather.gov, it gives it at locations like Richmond and EMI up near Baltimore, but it doesn't do a good job interpolating between all of those. What I've found pretty useful to do is with SkyVector, pick a bunch of your routes. SkyVector actually calculates a navlog using this button over here after you pick all of those points along the way. And you can pick airports, you can pick really anywhere by just dragging a point. Let me give that as an example. Drag a point and say plan a GPS location. Or you can drag a point and say plan a fix like VPace. But if you come over here and click a nav log, what it does is for each one of those points, it'll calculate the winds, 332 at 24, given that you're doing a climb, 288 at 28, given that you're at 6,000 feet. And then as you continue your entire route, it does a much better job probably than you or I, interpolating those winds along the route, given those wind stations that you would pick up from aviationweather.gov. So good to use these ones, or good to use the aviationweather.gov with your own interpolation. Okay, so we got the winds, that's in degrees. We've got a true airspeed number down here, and from the POH, depending on your aircraft, for the Cherokee, that one's actually in miles per hour. So up here, it actually gives a field where it calculates that. So that's the conversion, 89 miles per hour to knots. And knots are what's used in all the calculation, because the winds that we get from aviationweather.gov or SkyVector are going to be in knots. This is another quick place that you can put it in. 120 miles an hour converts to 104 miles an hour. So I can actually fill that out all the way down here the rest of the way. And for some reason, when I did that, it counted it. So I'm actually just going to paste the 104 instead of dragging. Okay. Over here on true course, couple ways you can get true course. You can get true course from, let me actually unhide a couple fields here. You can get true course. I want to, yeah. You can get true course from using your plastic dials on a sectional chart, or you can come over here to SkyVector and pick up some of those true courses. But I just want to emphasize something. SkyVector does a weird number in between where, for example, if I click from 2 Whiskey 6 to VPace, it says 239. And I just want to confirm if that is a true course or a magnetic course. And following the flow of the nav log, you have to start with a true course, and then later on, you do that correction for plus west or minus east. So looking at SkyVector, it says 239. I could pull up my wheel and see what that is, but just want to show you something. If I drag this directly south, right? I would expect that to say a course of 180. So I'm going to plan this just for a second to show it. I'm expecting it to show 180, but in fact it shows 191. What it's doing is it's already adding in that plus 11. So if you're using SkyVector to get a course, just recognize that that number that they're showing you adds in the 11 degrees west, or if we're over here, adds in 10 degrees west. So when you're using this number 239, you'd actually have to back it out before you put that in your course over here. So this is not the one that we're using for tracking, but this goes through the calculation. Let me change this to like 239 minus 11 makes it 228. It's going to run, it's going to check it over here, but use that 239 minus 11 or whatever your number is from SkyVector. Okay, so put in 228 here, runs the rest of the calculations. 228 includes a wind correction angle based on the 260 at 7. That's winds at that altitude or along that altitude if I'm doing the climb. I would input this number here of 11 or 10 or 12 or whatever it is. That's my variation from plus west and minus east, and then if there's any deviation based on the compass card. Get a final number over here. This is what I should actually turn to on my compass based on wind correction angle, variation, and deviation. I can also get legs, the distance off of SkyVector. That's pretty easy, and they do that correctly over here. It's in nautical miles. It gives that total distance along the leg, so I can calculate it from SkyVector 5, and it's got a remaining number over here. Ground speed, it does in this table actually run the calculation based on 77 knots for my true airspeed and the winds of 300 at 20 or whatever those numbers is. It runs a ground speed. What we would then fill out is based on our GPS, what's our actual ground speed that we're getting, just so we can compare those and see if we think we're going to end up ahead of time or early. Gives a calculated estimated time en route, 9 minutes. We could then fill out an actual time en route. And if we wanted to, there's another column for arrival time that we could start filling in based on when we took off, which is a field that we can fill out. But that's just a quick bit of information on some of the nuances of this sectional, of this VFR planner. Maybe using SkyVector to get some winds, maybe using SkyVector to get some distances, and those headings that you'd start with.